I want you to actually pause the video here and do this activity and answer the question of what do you notice. Okay, with example 1 here, our goal is to solve for x, so we have to isolate x. In order to do that, we need to get the square root by itself. So we'll subtract 7 from both sides, as you can see, leaving us with the square root of 2x minus 1 equals 3. Well, from here, we have to undo the square root, which would be squaring both sides. Squaring both sides, remember, square root and a square are inverse operations, so they'll cancel each other out, leaving us with 2x minus 1 equals 9. Then we solve for x. So add 1 to both sides, so we get 2x equals 10, divide by 2, x equals 5. And that bottom part there is us checking, making sure that our solution is correct and doesn't create an extraneous solution. So 7 plus the square root of 2 times 5 minus 1. 7 plus 2 times 5 is 10. 10 minus 1 is 9. So 7 plus the square root of 9. Square root of 9 is 3. 7 plus 3 is 10. 10 equals 10. That checks out. Okay, with example 2 here, we have the square root of 2x minus 1 equals x minus 8. One thing I do want to point out, and this is that fun activity you guys did as well, that the square root of 2x minus 1 actually could be written as 2x minus 1 to the 1/2 power. Because, again, from that slide, we realized anything raised to the 1/2 power is the same thing as a square root. So you will have some problems like this in your textbook, so I wanted to change it to 2x minus 1 to the 1/2 power equals x minus 8, so you can kind of see how you would need to solve that. So what we have to do, we would have to square it, and we square it because that is the 1/2, or 2 is the reciprocal of 1/2, because essentially what you're trying to do is you're trying to make your exponent 1. So we raise both sides to the second power, so we get 2x minus 1 equals, now x minus 8 to the second power is x minus 8 times x minus 8, which is x squared minus 16x plus 64. And then we need to, because it's a quadratic equation, we'll have to get the equation equal to 0. So I subtract the 2x and the 1, and we have 0 equals x squared minus 18x plus 65. And then from there, we need to factor to solve that equation. So a times c is 65. My factors of 65, that would add to negative 18, are negative 5 and negative 13. So I rewrite that as x squared minus 5x minus 13x plus 65. And then factor by grouping. Factor out the x from the x squared minus 5x, leaving us with x parentheses x minus 5. So, factor out the negative 13, leaving us with negative 13 x minus 5. And from there, we can factor out the x minus 5, and then what remains is the x minus 13. So our two factors are x minus 13 and x minus 5. Using the zero product property, we can set each factor equal to 0. So x minus 13 equals 0, solve, we get x is 13. 0 equals x minus 5, solve for x, we get x equals 5. Then we can check both of those, which is what I was doing at the bottom there. 2 times 13 is 26. 26 minus 1 is 25. The square root of 25 is 5. 5 equals 13 minus 8, which is 5. 5 equals 5, that checks out. When we plug 5 in there, 2 times 5 is 9. 9 minus 1 is 3. The square root of 9 minus 2 minus 5 is 10. 10 minus 1 is 9. The square root of 9 is 3. But 5 minus 8 is negative 3. So 3 does not equal negative 3, which means 5 creates an extraneous solution, which means it is really not a solution to the problem. So the only solution for example 2 is x equals 13. Okay, example 3, we have 4 parentheses x minus 9 to the 1/3 power equals 8. Just like with the first example, we had to get the square root by itself. Well, in this example, we want to get the x minus 9 to the 1/3 by itself. So let's divide both sides by 4, and then we'll have x minus 9 to the 1/3 power equals 2. Just like last example, we have to raise the 1/3 power to the reciprocal power. So raise that whole expression to the reciprocal power, which is 3, because 1/3. Remember, using our power of exponent or properties of exponents, a power raised to a power means you multiply the exponents, and 1/3 times 3 over 1, or 1/3 times 3 is 1. So that eliminates that exponent. So we'll have x minus 9 to the first power, so x minus 9 equals 2 to the 3rd power, which is 8. add the 9 to both sides, so we get x equals 17, and then check, make sure 17 is a solution. So 17 minus 9 is 8. 8 to the 1/3 power is 2. 2 times 4 is 8. 8 equals 8. Therefore, it is a solution. Okay, example 4 is definitely a special case here. So we have x minus 2 to the 2/3 power equals 9. So you might think, all right, great, we'll just use the last example. We'll raise it to the 3/2 power to both sides and call it good. And to an extent, you're not wrong. The trick here, though, is because we have an even root. I kind of worded that wrong. It should be an even exponent. What I mean by that, so even replace the word root with exponent. So that 2 indicates that it's x minus 2 squared, and then the 3 is the root. So really that could be rewritten as the cube root of x minus 2 to the 2nd power. So because of that fact, we have to guarantee, because it's being squared, we know that it could be the positive value, or it could be the negative value, because any number, as soon as it's squared, it will end up being positive anyway. So anytime you have an even exponent like that, again, that should not say even root, it should say even exponent. Anytime you have an even exponent like that, you have to use absolute value. So here's how the absolute value is used. Okay, so we have x minus 2 to the 2/3 power equals 9. Like I suggested earlier, we're going to raise both sides to the power of 3/2 in order to use the power of the power and multiply and get an exponent of 1. So we'll get x minus 2 equals 9 to the 3/2 power is 27. This is where the absolute value comes into play. We put an absolute value around the x minus 2. And then we have to recall back from chapter 1 when we solved absolute value equations. If you remember, we would create 2 separate equations. So we would have the equation x minus 2 equals 27 and x minus 2 equals negative 27, because the absolute value of positive 27 is 27 and the absolute value of negative 27 is 27. So we try to find the value of x that can give us a positive 27 and a negative 27. So then we solve each of those equations. Add 2, 27 plus 2 is 29, so we get x equals 29. Add 2 to negative 27, we get negative 25. So right now we have 2 solutions, 29 and negative 25. We need to check them both and make sure they both work and neither are extraneous. So 29 minus 2 is 27, and 27 to the 2/3 power is 9. 9 equals 9, that checks out. Negative 25 minus 2 is negative 27, and negative 27 to the 2/3 power is 9. So again, 9 equals 9, that checks out. So example 4, this problem has 2 solutions, 29 and negative 25. Again, remember, the biggest thing here is when you have an even exponent, you have to make sure you have the absolute value symbols there.